We make measurements and then we do calculations with them, and it's important that the precision of our measurements be maintained as we're doing those calculations. Significant figures are those digits that carry meaning, contributing to its precision. So we need to be able to count these significant digits. And then we're going to learn how to add, subtract, and then multiply and divide to maintain the correct precision. Counting significant digits. Well, really the only thing we have to worry about is zeros, because all non-zero digits are significant. So if you see a 1 or a 7 or an 8, those are all significant. Zeros might be, and they might not be, and you have to figure out when are they and when are they not. Well, the first thing is, if a digit is between two other significant digits, it's significant. So the number 12, well, that has two significant digits. The number 102, well, that has three significant digits. The 1 is significant because it's not 0. The 2 is significant, it's not 0. That 0 is in between two significant digits, and so it is also significant. So this has 3. On the other hand, if that were 1020, that also is only has 3 significant digits. The 1 is significant, the 2 is significant, that one in between is, but this one, it's not. It's not in between two. And it also doesn't meet the other case, which is this rule. A 0 on the right hand end, oh, but that was on the right hand end, behind the decimal. Well, it's not behind the decimal. There's no decimal written in this number. And if there were, it'd be right here. And that 0 is not behind it. So it's not significant. Zeros in between and zeros on the end behind the decimal are significant. So if I write the number 1020.0, this 0 is significant. It's on the right-hand end behind the decimal. Well, what about this one? Well, now it's significant because 2 is significant, that 0 is significant, it's in between, so it is now significant. 2 is because it's not 0, that 0 is because it's in between, and that's not 0, so it's significant. So this number has 5 significant digits. Okay, so if it's not 0, it's significant. If the 0 is between two significant figures, it's significant. And if it's on the right-hand end, to the right of the decimal, on the end to the right of the decimal, then it's significant. Let's practice. So how many significant figures are here? Well, that's not, and that's not. These are called leading decimals. You move from left to right, and nothing is significant until you get to your first non-zero. So not. This is. How about this one? Well, it's not in between, but it's on the right-hand end behind the decimal, so yes, that's significant, and that has 2 significant figures. Well, let's look at this one. This is significant. This is significant. That makes these 2 significant. Well, how about this one? It's on the right-hand end behind the decimal, so it is. So that number has 5 significant digits. How about this? These, remember, these are leading zeros. They're not significant. You keep on moving from left to right until you get to a non-zero. These are not significant. This is. So that number only has 1 significant figure. This is significant. How about these? Well, they're not on the right-hand end behind the decimal. They're not significant. So 200 has 1 significant figure. The 2 is significant, the 6 is significant, these 2 are in between, so 2006 has 4 significant figures. Significant, not. So 3 significant figures. By now this one should be pretty simple. What do you think? 1 significant figure. The 5 is? Nothing else is significant. These are leading zeros, which means, right, that they're not significant. So this has 2. This is significant because it's not a 0. This 0 is on the right-hand end to the right of the decimal, right? Here's your decimal. This is the end behind the decimal. This is significant. That means that this is because it's in between. So 3. This is, that makes the 2 zeros significant. This is on the right-hand end behind the decimal. It is. That makes this significant because it's in between. 1, 2, 3, 4, 5, 6. 6 significant figures. Okay? Good job. So when you've done a problem, you might need to be able to take the answer that you've gotten and rewrite it to have the correct number of significant figures. So let's look at this number and rewrite this number, the 6,352,000, with one significant figure. Okay, the deal here is not that we're trying to change the value significantly, we're rounding it. Okay, so one significant figure, that means the biggest digit is the one that's going to have to be significant, so that would be that 6. And then all of these others are going to have to turn into zeros. So we're rounding 6,352,000 to just 6 million, and that's how you would write it. Sorry, I didn't mean to scribble there. 6 million, 6, 1, 2, 3, 4, 5, 6 zeros. Now another way to do this that makes it simpler, and that we'll need to for these parts, is to write this number in scientific notation. Now remember, standard scientific notation says a single digit, a decimal, your other digits, 3, 5, 2, times 10 to the, well, let's see, we moved our decimal 1, 2, 3, 4, 5, 6 places, times 10 to the 6th. So if I round this to have one significant figure, then this would be written as 6 times 10 to the 6th, and that's one significant figure. Well, how do I write this with two significant figures? Well, if I look at the standard scientific notation version, it's really simple. That means I get to round to where the 3 is, to the 10th place. Well, I have to round. I don't throw this stuff away. I round. So I look to the right of the 3. There's a 5. That tells me I have to add 1 to the 3. And so that's 6.4 times 10 to the 6th. And that has two significant figures. Now the power of 10 doesn't change. I haven't multiplied or divided this by anything. It's the 6 that's here comes from all of those. We divided by 10 6 times to move our decimal over, and we haven't done anything to that, so it stays the same. Three significant figures. Well, the 6, the 3, and now the 5 can be significant. We have to round, but that's a 2, so the 5 stays a 5. So 6.35 times 10 to the 6th. 4 significant digits. Well, you've probably figured this out already. It's going to be 6.352 times 10 to the 6th. Well, how do we increase the number of significant digits? We need 5 now. You add a 2 here. Add a 0 here behind the 2. So 6.35 20 times 10 to the 6th. This is significant because it's on the right-hand end behind the decimal. So now we have 1, 2, 3, 4, 5 significant digits. Writing numbers in scientific notation really helps with counting and rounding to specific numbers of significant digits.